Welcome to the Deep Dive. Today we're going to be diving into natural language processing, or NLP for short.
It's more than just a buzzy word, though. Like, NLP is changing, how we're interacting with computers and just with information in general.
Yeah, so full disclosure, before we got into this, I'll admit I was a little bit fuzzy on what NLP even was. I thought it was mostly those AI chatbots that everyone's going crazy about right now, but I was way off, huh?
Definitely. Yeah, the chatbots, are kind of like a prominent example, but NLP it's a lot broader than that. It's really like the force behind a lot of the tech that you use every day, from search engines, to spam filters, to even like those personalized recommendations you get on shopping sites.
So basically it's all about teaching computers to understand human language. I mean, not just the words themselves, but the meaning behind them.
Exactly. It's like bridging the gap between how we think and communicate as humans and how computers process information, right?
Yeah, I'm starting to see why this is such a big deal. But let's break it down for anyone who's maybe new to this. What are the real world implications of NLP? Why should our listeners care?
Well, think about it this way. NLP is making technology more intuitive and more user-friendly. So instead of typing in rigid keywords, now you can talk to your devices naturally, and they actually understand what you mean.
Oh, I love that.
It's making tech work for us, not the other way around.
So it's not just about making things easier. It's about creating this more personalized, human-centered experience with technology.
Absolutely, but there's more to it. NLP is helping us tackle these really complex problems in different fields.
Like what? Give us some concrete examples.
Okay, let's take healthcare. NLP is being used to analyze medical records and research papers, even patient conversations, to pull out valuable insights. This can help doctors diagnose diseases earlier, personalize treatments, and even speed up drug discovery.
Okay, that's pretty amazing. Healthcare is a field where NLP can really make a difference. What about other areas?
Okay, in finance, NLP is being used to analyze market trends, assess risk, and even detect fraud. So algorithms, they can scan through massive amounts of financial news and data, to make predictions and inform investment strategies.
So NLP it's basically like having an army of tireless, hyper-intelligent assistants working behind the scenes to improve our lives and solve these complex problems.
That's a great way to put it. It's augmenting our capabilities and helping us accomplish things that we couldn't do before.
This is all incredibly fascinating. But I got to ask, how does NLP actually work its magic? What's going on under the hood?
You can kind of imagine NLP as this multi-stage pipeline. So
Yeah.
Raw text enters one end, and meaningful insights come out the other.
I like that analogy. So what's the first step in this pipeline?
So the journey begins with text-free processing, where we clean and prepare the text for analysis.
Oh, okay. It's like prepping ingredients before you cook. You need to wash and chop and measure everything to make sure that the final dish turns out, just right. So we're basically making the text digestible for the computer.
Exactly. We remove irrelevant characters and convert everything to lowercase, and we break down the text into these individual units called tokens.
Tokens, are those the building blocks of language for the computer?
Precisely. So these tokens, they can be words, phrases, or even sentences. Mm-hmm. And then to simplify things even further, we often remove common words like the and a and is, which don't really carry much meaning on their own. Those are called stop words.
It's like decluttering the text to focus on the essential elements.
Exactly. And once we have these nice, clean, tidy tokens, we can then apply techniques like stemming and lemmatization to reduce words to their root form. So, for example, running, ran, and runs, they would all be reduced to run.
So it's like grouping similar words together to make the analysis more efficient.
Exactly. This helps the computer recognize that, different forms of a word have essentially the same meaning.
Okay. This is starting to make sense. So
Yeah.
So once we've pre-processed the text, what's next in this magical NLP pipeline?
The next step is where things get really interesting. It's called feature extraction, where we turn words into numerical representations that computers can understand.
Hold on. Turning words into numbers. How do you even do that?
Yeah, it's a bit like, translating from one language to another. We can't feed raw text to a computer, so we need to convert it into a format that it can process, which are numbers. There's several techniques for doing this, and each has its own, strengths and weaknesses.
Okay. Give us a glimpse into some of these techniques. What's a common approach?
One of the most intuitive methods, it's called bag of words. So imagine you have this bag filled with all the unique words from your text. Each document or sentence is then represented by a vector that counts how many times each word from the bag appears.
So it's like creating a unique fingerprint for each piece of text based on its word composition.
Oh, precisely.
Yeah.
It's a simple but powerful way to represent text numerically, making it digestible for machine learning algorithms.
This is blowing my mind. But I'm guessing there are more sophisticated techniques out there.
Absolutely. Another popular one is called TF-IDF. It stands for Term Frequency Inverse Document Frequency.
Oh, wow.
It's a fancy way of saying that we're not just considering how frequently a word appears in a document, but also how rare it is across all documents.
So if a word appears a lot in one document, but it's rare overall, it gets a higher weight.
You got it. So this helps us identify words that are particularly characteristic of a specific document. It's incredibly useful for tasks like, document classification or searching for relevant information.
I'm starting to appreciate the complexity involved in turning words into something that a computer can understand. But it sounds like there's even more to this, right?
There is. So in recent years, word embeddings have become super popular. So instead of just counting words, they actually capture the semantic relationships between words, meaning that words with similar meanings will have similar numerical representations.
So it's like mapping words onto a multidimensional space where their location reflects their meaning.
Precisely. And this allows us to go beyond these simple word counts and capture more nuanced aspects of language.
This is all so fascinating. But before we get lost in all the technical details, I want to bring it back to our listeners.
Yeah.
Why should someone who's just starting out in NLP care about all these different techniques for representing words?
It's all about choosing the right tool for the job. Understanding the strengths and the weaknesses of each technique allows you to tailor your approach to the specific NLP task you're trying to tackle. So whether you're, building a chatbot, analyzing customer reviews, or developing a medical diagnosis tool, selecting the right feature extraction method can have a huge impact on your results.
That makes perfect sense. So it's not just about knowing like what these techniques are. It's about understanding when and how to use them effectively.
Exactly. And as you dig deeper into NLP, you'll discover even more advanced techniques and learn how to combine them in creative ways to achieve your goals. It's a field that's constantly evolving, which is what makes it so exciting. Welcome back to the deep dive. In part one, we covered a lot of ground, laying the foundation for understanding how computers grapple with the complexities of human language.
Yeah, we talked about how NLP is kind of like this multi-stage pipeline where we take raw text, we clean it up, break it down, and turn it into something that computers can actually understand, right?
Exactly. And now that we've prepped our ingredients, it's time to dive into the main course. It's text analysis. This is where the real magic happens. It's where computers go beyond just like recognizing words to actually understanding their meaning and their relationships.
Okay, color me intrigued. What kind of sorcery are we talking about here?
Well, it's not quite sorcery, but it's pretty close. Text analysis is where we extract meaning and insights from the text. You can think of it as like unlocking the secrets hidden within the words.
Ooh, I like that. Unlocking secrets. So how do we go about doing that? What are some of the key techniques involved?
One of the fundamental techniques is called part of speech tagging, or POS tagging for short. It's all about labeling each word in a sentence with its grammatical role.
So we're talking about like nouns, verbs, adjectives, all that good stuff.
Exactly. It's like giving the computer a basic grammar lesson. By understanding the grammatical function of each word, the computer can start to understand the structure of a sentence and how the words relate to each other.
Yeah, that makes sense. It's like teaching the computer to parse a sentence, just like we do in school, right?
Precisely. And once we have a grasp of these grammatical roles, we can move on to something called named entity recognition, or NER for short.
Okay, NER. That sounds pretty intense. What exactly is that?
NER is all about identifying and classifying named entities in text. So these are things like names of people, organizations, locations, dates, and so on.
So it's like giving the computer the ability to pick out the key players and places in a story.
You got it. NER is incredibly useful for tasks like, information extraction, question answering, and summarizing text. Imagine being able to automatically extract all the key people, organizations, and locations mentioned in a news article, for example. That's the power of NER.
Okay, I'm starting to see how these techniques can be used to like unlock these valuable insights from text. But I'm guessing there's more to it than just identifying parts of speech and named entities, right?
You're absolutely right. Another crucial aspect of text analysis is understanding how words relate to each other within a sentence. And that's where dependency parsing comes in.
Dependency parsing. All right, break it down for me.
Imagine drawing a diagram of a sentence where each word is like a node and arrows connect the words to show their grammatical relationships. That's essentially what dependency parsing does. It analyzes the grammatical structure of a sentence to reveal how the words depend on each other.
So instead of just looking at words in isolation, we're now understanding how they interact with each other to create meaning, right?
Precisely. Dependency parsing helps us unravel the complexities of sentence structure, allowing the computer to grasp the underlying meaning of a sentence.
This is all starting to sound like we're building a pretty sophisticated understanding of language in the computer's mind.
We are, and we're not done yet. Another fascinating area of text analysis is sentiment analysis.
Sentiment analysis, yeah. I've heard that term thrown around before. It's about understanding emotions in text, right?
Exactly. Sentiment analysis is all about determining the emotional tone or attitude expressed in a piece of text. Is it positive, negative, or neutral? Is the author, happy, sad, angry, or excited?
Wow, that's pretty incredible. So the computer can actually like sense the emotions behind the words.
It's getting better at it all the time. Sentiment analysis has a wide range of applications, from understanding customer reviews to gauging public opinion on social media to even detecting potential mental health issues based on text patterns.
That's mind-blowing. Yeah. But how does the computer actually figure out the sentiment? Is it just looking for like keywords like happy or sad?
It's a bit more sophisticated than that. Sentiment analysis algorithms consider a wide range of factors, including word choice, punctuation, context, and even emojis. They learn to recognize patterns in language that correlate with different emotions.
So it's like the computer has developed its own like emotional intelligence.
You could say that. And this ability to understand emotions in text opens up a whole new world of possibilities.
I can only imagine. Okay, so we've covered POS tagging, NER, dependency parsing, and sentiment analysis. Are there any other key techniques we should know about?
There are many more, but one worth mentioning is topic modeling. It's a way of automatically discovering the main themes or topics that run through a collection of documents.
So instead of like manually reading through tons of text and trying to figure out what it's all about, we can use topic modeling to get a quick overview of the key themes.
Exactly. It's like having a super smart librarian who can organize a library by grouping similar books together. Topic modeling can help us make sense of large amounts of data, whether it's news articles, research papers, or social media posts.
This is all so incredibly fascinating. But I have to ask, how do these techniques actually work in practice? Can you give us some real world examples?
Absolutely. Let's take customer service, for instance. Many companies now use chatbots powered by NLP to handle customer inquiries. These chatbots can understand your questions, even if they're phrased in different ways, and provide relevant information or solutions.
Yeah, I've definitely encountered those chatbots before. Some are better than others, though.
That's because the quality of a chatbot depends heavily on the underlying NLP techniques that are used to build it. A well-designed chatbot can understand complex language, handle multiple intents, and even engage in natural-sounding conversations.
So the more sophisticated the NLP, the more human-like the chatbot experience.
Exactly. And it's not just about chatbots. NLP is being used in countless other applications. Think about, spam filters that can automatically identify and block unwanted emails, or search engines that can understand your search queries and return relevant results. These applications all rely on text analysis techniques to make sense of human language.
This is all truly impressive, but I'm curious about the challenges involved in text analysis. Human language can be so nuanced and ambiguous.
Right.
How do these techniques handle those complexities?
That's a great question, and you've hit on one of the biggest challenges in NLP. Human language is full of subtleties, idioms, sarcasm, double meanings. It's what makes language so rich and expressive, but it also makes it incredibly difficult for computers to fully grasp.
Yeah, I can imagine.
Yeah.
So how do researchers address this challenge?
It's an ongoing area of research, but there are several approaches. One is to develop more sophisticated algorithms that can take context into account. For example, instead of just looking at individual words, these algorithms consider the surrounding words, the sentence structure, and even the overall topic of the text.
So it's about teaching the computer to read between the lines, so to speak.
Exactly. Another approach is to incorporate more data into the training process. The more examples of human language a computer sees, the better it becomes at understanding the nuances and complexities.
It's like anything else. The more you practice, the better you get.
Precisely. And as NLP continues to evolve, we can expect to see even more sophisticated techniques for handling the challenges of human language. It's a field that's constantly pushing the boundaries of what's possible.
This has been an incredible deep dive into the world of text analysis. I'm starting to appreciate just how much goes into making computers understand human language. But I have a feeling there's even more to explore, right?
You're right. We've only scratched the surface of what's possible with text analysis, and then in the next part we'll delve even deeper into this fascinating world of NLP, exploring some of the advanced techniques that are shaping the future of how we interact with computers and information.
Welcome back to the deep dive.
Sure.
In the previous parts, we went through this intricate world of natural language processing, from like pre-processing text to actually like unlocking its meaning using text analysis techniques.
We saw how computers can actually be trained to understand the nuances of human language, from identifying parts of speech to, even recognizing emotions in text.
It's really remarkable how far NLP has come. But as you mentioned in part 2, there's still so much more to explore. So what other fascinating frontiers await us in the world of NLP?
Well, one area that's particularly exciting is the development of large language models, or LLMs for short.
LLMs. Those sound intriguing. What are they all about?
Think of LLMs as kind of like the culmination of all the techniques that we've discussed so far. They're massive neural networks trained on huge, colossal amounts of text data, enabling them to perform a wide range of language-related tasks with remarkable accuracy.
So they're like the super brains of the NLP world.
That's a great analogy. LLMs are capable of generating human-quality text, translating languages, writing different kinds of creative content, and answering your questions in an informative way, even if they're, open-ended, challenging, or strange.
Okay, that's seriously impressive. It sounds like LLMs are taking NLP to like a whole new level.
Mm-hmm. They are, and they're already having a profound impact on various fields. For example, in customer service, LLMs are powering chatbots that can handle complex inquiries, provide personalized support, and even anticipate customer needs.
It's like having this virtual assistant who can understand like your every whim.
Exactly. And in content creation, LLMs are being used to write articles, generate marketing copy, and even create scripts for movies and TV shows.
Hold on. So you're telling me that some of the content we consume might actually be written by AI?
It's more common than you might think. LLMs are becoming increasingly adept at generating human quality text, blurring the lines between human and machine creativity.
That's both fascinating and a little unsettling. It raises all sorts of questions about the future of writing and authorship.
It does, and those are important conversations to have. But beyond the potential disruptions, LLMs also offer incredible opportunities. For instance, they can help us break down language barriers, making information accessible to people all over the world.
That's a powerful application. Imagine being able to communicate seamlessly with anyone, regardless of
of
their native language.
Exactly. And that's just the tip of the iceberg. LLMs are constantly evolving, and researchers are discovering new and innovative ways to use them. It's a field that's ripe with possibilities.
This is all incredibly exciting, but I have to ask, what about the limitations of LLMs? I mean, they can't be perfect.
Really? Of course not. Like any technology, LLMs have their limitations. One challenge is that they can sometimes generate, biased or inaccurate information, reflecting the biases present in the data that they were trained on.
So it's crucial to be aware of the potential for bias and to use LLMs responsibly.
Absolutely. Another challenge is that LLMs can be, computationally expensive to train and deploy. They require massive amounts of data and processing power, making them accessible only to those with significant resources.
So while the potential of LLMs is immense, there are still hurdles to overcome in terms of accessibility and ethical considerations.
Exactly. But as research progresses and technology advances, we can expect these challenges to be addressed. The future of NLP is bright, and LLMs are poised to play a transformative role in how we interact with language and information.
This has been an incredible journey into the world of NLP. We covered so much from the basics of text pre-processing to the mind-blowing capabilities of large language models. I'm walking away with a newfound appreciation for the power and potential of this field.
And that's what the deep dive is all about. We've only scratched the surface, but hopefully we've sparked your curiosity and inspired you to explore further. The world of NLP is vast and ever evolving, so there's always something new to discover.
And that concludes our deep dive into natural language processing. We hope you've enjoyed the journey and that you're leaving with a better understanding of this incredible field that's shaping the future of how we communicate, learn, and interact with the world around us.